Classify the chemical nature of the reactants. Sulfurous acid, H2SO3, is explicitly identified as a weak acid. In aqueous solution, weak acids are weak electrolytes and do not extensively ionize. Therefore, they must be written in their intact molecular form, H2SO3, in both complete and net ionic equations. Barium hydroxide, BaOH2, is a soluble strong base. Strong bases are strong electrolytes that dissociate completely in aqueous solution into their constituent ions, Ba to the power 2 plus and OH to the power negative. Identify the products of the neutralization reaction. The reaction between H2SO3 and BaOH2 is an acid-base neutralization that forms water, H2O, and the salt barium sulfite, BaSO3. The prompt states that a precipitate forms. Therefore, barium sulfite must be represented as an insoluble solid, BaSO3. Write the complete molecular equation. H2SO3 plus BaOH2 gives BaSO3 plus 2H2O. Write the complete ionic equation. Dissociate only the strong electrolyte, BaOH2, while keeping the weak acid, solid precipitate, and liquid water intact. H2SO3 plus Ba to the power 2 plus 2OH to the power negative gives BaSO3 plus 2H2O. Identify and eliminate spectator ions to find the net ionic equation. Spectator ions are species that appear in the exact same form on both the reactant and product sides of the equation. In this reaction, every single ion undergoes a chemical change, forming either insoluble solid BaSO3 or molecular liquid H2O. Since there are no spectator ions, the complete ionic equation is also the net ionic equation. This matches option B. The correct answer is option B. H2SO3 plus Ba2 plus 2OH minus gives BaSO3 plus 2H2O.